In this video, we will continue where we left off. So basically, we're going to look at more examples of solving inequalities. So simply more examples going through the same process. Now, for polynomial, you can have two types of things happening here. Okay, first is it's given in factored form. That's going to be less work. And second, it is not in factored form, which means you have to first, i.e. first step will be factoring. Okay, now which means for factoring, again, I'm not going to go over the techniques that you've already seen for different kinds of polynomial and how they can be factored. Okay, for rational, again, the same idea is ultimately, right, you want both numerator and denominator factored if it is not factored. Let's look at quick example for polynomial factored. So that will be our example number 1. So suppose it says solve x minus 1, x minus 3, x minus 5 greater than 0. So here's my solution. Step 1, I'm going to find the zeros. So since it's already in factored form, solving this will directly give me the 3 numbers I'm interested in. Oops, it's not in the same format. 1, 3, 5. Step 2, you're going to mark those out. 1, 3, 5. Some way to indicate that these other numbers are different. I'll use a different color. Pick these test points. In this case, there are 4 test points. Step 3, I'm going to plug in each of these numbers. And again here, having it in factored form is going to be helpful because you can just look at the sign of each factor. Right? So it's going to be a negative number times a negative times a negative, which will be negative. 2, 2 minus 1, 2 minus 3, 2 minus 5. Positive, negative, negative, which will be a positive. 4, 4 minus 1, 4 minus 3, 4 minus 5. It's a positive, positive, negative, be negative, and you guessed it correctly, the last one will be all positives, which will give us a positive. Eventually, the last step, we will redraw what we have from step 2, but instead of writing the test points, I will write the result of the signs, negative, positive, negative, positive. Then I'll look back what the question is asking me. The question is asking me where it is positive. It's positive from 1 to 3 and 5 and to infinity. Okay, so pretty straightforward problem. Now let's look at polynomial unfactored. Okay, so maybe they will ask you something like x cubed minus x squared plus x minus 1 greater than 0. Right, so one of the techniques, we will factor by grouping. Factor by grouping, I have x squared, x minus 1 plus 1, x minus 1. X squared plus 1, x minus 1. And now, you just go back to the same method as problem number 1. Because now you can deal with this like you were like this is a new problem, like this is where you started, and this is a factored polynomial given to you. All right, the next one we're going to look at is irrational factored. Now what happens for irrational is essentially you have two polynomials, right? So you have one polynomial in the numerator and one polynomial in the denominator. So in some manner, it's not entirely very different, right? So the same thing's sort of going to follow. Suppose I want to find out where this is greater than 0, right? Now, the only difference is going to be in step 1, because step 1, there's going to be two kinds of things we find. We're going to find the x-intercepts, and we're going to find the vertical asymptotes, which do not exist in case of polynomials. X-intercept is numerator equal to 0, gives x's 1 and 3. And vertical asymptote is denominator equal to 0, which is -1 and -3. So again, it's basically, if it's factored, we are saved the work for factoring. Step 2 is, now instead of just plotting the intercept, that is the zeros, we will plot all 4 points. So we have 1, 3, -1, -3. And now when you're picking test points, there's going to be way more test points, right? So pick 0, there's a 2, you can pick a 4, pick a -2, -4. And step 3, again, a bit tedious. You have to check for all of these numbers. So -4, -2, 0, 2, 4. Okay, so I'm going to skip plugging in the values. I'll just look at the result of each factor. -4 means I will have a negative number and a negative divided by a negative and another negative. That's an even number of negatives, so that's going to be a positive. Next one is going to be negative, negative, divided by negative, positive, which will be negative, 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 positive, 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 negative, positive, positive, negative, and positive, 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 positive. That's a positive. And I will summarize my findings by redrawing the number line from step 2 and replacing the test points by the signs that I've just found. So positive, negative, positive, negative, positive. And then I will report my answer based on what is needed. I want it to be greater than 0. So the solution is -infinity to -3, union -1 to 1, union 3 to infinity. And the last type of problem you can have is rational unfactored. Well, what happens there? So maybe you're asked to solve. Let's take that some similar polynomial divided by, and then x squared minus 5x plus 4 less than 0. Essentially, the extra step is we will need to factor both numerator and denominator. The numerator we can factor by grouping. The denominator we can factor by splitting the middle term. Okay, so we have x squared, x minus 1, minus 1, x minus 1, x squared minus 1, x minus 1. Here we can go a step further because that's x minus 1. Okay, so don't worry about the square because the process is the same. It's going to give you two intercepts and then test points and so on. The denominator, we will split the middle term as -4 and 1, sorry, x minus 4 minus 1, x minus 4. So the rephrased problem is the following. It's actually x plus 1, x minus 1 squared, x minus 1, x minus 4 less than 0. And guess what? One of the x minus 1 gets cancelled. So it's even simpler. Now just go to problem 3 and follow the steps. So that's it. That's the basic idea for solving any inequality, which we've just applied to the case of a polynomial and a rational expression. That's it for this particular topic.